My name is Dr. Tyler Adams, and this is the Adams Research Lab. We work on extended viologen molecules, which basically means that they are fully organic and they change color, they fluoresce, and have very good electron accepting and donating properties, and that makes them useful for a lot of applications. The projects that we're working on, Jacob's working on this biotag idea of basically taking our fluorescent molecules and then attaching some kind of biomolecule onto it. And so one of my big wonders for it is, can we attach our fluorescent molecule onto an amino acid or an RNA, and then we can actually track some of those processes and actually learn a lot more. What's interesting about these being able to gain electrons, that's where the color changes really happen. And then I have my master's student working on redox flow batteries. So what that is, we have solar cells and we have windmills and all that kind of renewable energy, but it's not always sunny, it's not always windy. And so what do you do with the electricity that's being made? How do you store it? And you can't really do lithium-ion batteries because they'd have to be the size of this room to store electricity for Atlanta, right? And so one of the ideas is redox flow batteries, where you're actually using these molecules. They're called viologens, so I'm just gonna write this. Viologen 2+ going to viologen 0. And so you can store 2 electrons by having a solar panel or a windmill, whatever, produce electricity, and then you put those electrons into this viologen molecule. And so by doing that, that's how you charge it up. And then whenever you want that electricity back, you just pull it out. Here's a little bit of what we do with the color changing material. So this is just like a little laser pointer, and so you can draw different things. So that's just a plastic backing, and then that has our molecule throughout. We were talking about how our stuff gains electrons. This is just like a secret sauce of the molecule, which is yellow. Once it's exposed to that light, it'll actually grab electrons from the polymer and turn dark blue. And then we talked to a bunch of people about using this as an oxygen sensor, because over time, oxygen will come back and turn it back to yellow, and so we can use it for an oxygen sensor in food packaging. So like your potato chips are packaged under nitrogen. If oxygen gets to it and it turns it yellow, oh, they're stale. I don't want to eat them anymore.